Series 3.1 Sums of Natural Numbers. Here we are going to use sigma notation again, introduced in single maths. So remember, with sigma, so this is capital sigma, we have a number in this underneath. So r equals 1, so we start summing the series from 1 and we stop at the third term. So for this example, you can see the rule is 10r minus 1. So for the first term, we do 10 times 1 and then subtract the 1 and repeat that for the second and the third terms, giving us a total of 57. If, for example, it was the sum of the first n r squared terms, so 1 squared plus 2 squared plus 3 squared, etc., up to n squared. So in this topic, we're going to learn more about simplifying some of these into formulae that we can then speed up the process. So the first one I'm going to look at is this one. So n sigma, so the sum of the first n terms, given that the rule is 1. So this is equal to 1 plus 1 plus 1 all the way up to the nth term. Well, hopefully you can see here that if there are n terms, 1 is a common factor. So we're doing 1 times n times. So therefore it is just n. Next, we're going to look at the sum of the first n natural numbers. So r equals 1 and the rule is r. So when r is 1, we have a first value of 1. When r is 2, second value is 2, etc., all the way up to the nth term. Now hopefully you can spot here, this is an AP, or an arithmetic progression, with first term 1 and common difference also 1. And remembering from single maths that the sum of an arithmetic series can be found by the formula n over 2, 2a plus n minus 1 times d. So filling those values in, we have the sum of the first n terms is equal to n over 2, 2 times 1 plus n minus 1 in brackets times 1, which is the common difference. So Sn is equal to n over 2. Simplifying inside, we have 2 plus n minus 1, and simplifying again, n over 2 inside the bracket n plus 1. And you will quite often then see this written in the following way: a half times n plus 1. So if we want to find the sum of the first n natural numbers, we can just use this formula. Example 1. In part A, we want to evaluate the sum of the first 4 terms using the rule 2r minus 1. So to do this, when r is 1, 2 times 1 minus 1, so that is equal to 1. The second term, 2 times 2 minus 1, so that is 3. The third term, 2 times 3 minus 1, so that is 5. And the fourth term, which gives us 7. So totaling those up gives us 16. Now, had that expanded on further, we could have recognised that it was an AP and we could have used the sum of an arithmetic series. Part B. We want to find the sum of the first 50 natural numbers. Well, we know that this is equal to, remember from above, that Sn is equal to a half n plus 1. So we can just use that formula to give us a half. There are 50 terms, so 50 plus 1, which gives us a total of 1,275. Part C. We want to find the sum of the 21st term to the 50th term. Now, we can think of this as being, if we have 50 terms, so 1, the first term, the second term, the third term, all the way up to the 20th term, 21st, 22nd, all the way up to the 50th. And what we want to find is the 21st term to the 50th term. So actually, to do this, it means we don't want the 1st to the 20th term. So we can actually think, let's find the total of all of them, and then from that, subtract the first 20 terms. So writing that out, we have this is equal to the sum of the first term to the 50th term minus the sum of the first term to the 20th term. Now, using our formula, this is a half, and we have 50 terms here, 50 plus 1, and from that we're going to subtract a half. This time we have 20 terms, which then gives us 1,275 minus 210, which gives us an answer of 1,065. Example 2. Here we want to find the sum of, from the 5th term to the 2n minus 1th term of the natural numbers. Well, this is equal to the sum of from the 1st term to 2n minus 1, and from that we're going to subtract the 1st term to the 4th term. And remember, our formula for the sum of natural numbers is a half n brackets n plus 1. So let's use that. A half, n in this case is 2n minus 1. And then we have 2n minus 1 plus 1. In the second one we have a half, this time n is 4. So let's tidy that up. Well, here we have a half, 2n minus 1, 2n, minus a half, 4, and 4 plus 1 is 5. So we can keep playing with this. Well, half is common, so I'm going to take that out. Then we have 4n squared minus 2n for the first two. And from that we're going to subtract 20. Multiplying through by a half, 2n squared minus n minus 10, and we have our answer. Example 3. Here we want to evaluate, so we want to calculate the sum of the first 25 terms using the rule 3r plus 1. Now we could start to write all that out and expand it, but there's actually a much quicker way. This is equivalent to the sum of the first 25 terms of using 3r, and adding on to that the sum of the first 25 terms using the rule add 1. This can be simplified further. So we can take 3 out, and on the second one that stays as it is. So now we can see we have 3, and here we can use the formula, a half times 25, 25 plus 1. And for the second one, well, we know that from previously, if we're just adding 1 each time and we're adding that 25 times, well, that is just add 25. So now we're at the point where we can just add those together. So we get 975 plus 25, which gives us an answer of 1000. Example 4. In part A, we want to find the sum of, or specifically a formula for this, first n terms using the rule 7r minus 4. Well, this is equal to 7r minus the sum of using 4. Well, this is the same as 7 times sum of r. Now for conciseness, I'm just ignoring the numbers top and bottom for the moment. Minus, well, the sum of 4, this is the same as 4 times the sum of 1. So that is between r equals 1 and n. r equals 1 and n. So now we can go, well, this is 7 times using our formula, a half times n plus 1, minus 4, and the sum of 1 n times is just n. So expanding that out gives us, let's go for this, we have a half. So that's a half is, let's take a half as common. So then we can have 7n, n plus 1. And if I look at the 4n, if I think, well, let's make that an 8, then that means we can bring it inside and half is common. So just checking that, a half times that gives me this, and a half times the 8n gives me the 4n. So we have a half 7n squared plus 7n minus 8n, which simplifies to which factorizes to give us our answer. Now, for part B. Part B says hence, so it means using the result from 1 to evaluate the sum of the 20th to the 50th term of 7r minus 4. Well, we know that that is the same as using our rule here, but this is going to be the same as the sum of the first 50 terms subtracting from that, from the first term to the 19th term. Now, using our formula from above, using this formula, we have a half times 50, 7 times 50 minus 1, and from that we're subtracting a half. This time n is 19, so 7 times 19 take away 4, which gives us an answer of 7,471.